Welcome back to Big Man's World of Wonders.
And I'm going to print one more of these pumpkins. Just one. The time lapse, you're going to see it has two. It was already done when I made this. And I said, hey, I should show some people how this is done because it's so cool. So this is what I'm going to do. I'm going to first start. I have to heat up the nozzle and I have to heat up the bed. Because when I have to level it, the heat changes the warping of it. It changes everything. Things change under heat as they heat and cool. So I'm going to go ahead and I'm going to start on here, and I'm going to go ahead and heat it up a little bit, get it going, so I can clean off the nozzle a little bit, and
don't forget to smash the subscribe button.
Get it going. Let's get this project underway. And now I'm going to, while that's going, I'll go ahead and heat the bed a little bit. And here we go. All right. So, what else can I tell you about that? On the back here, there's a piece we'll show you a picture of. It's called an extruder. This thing uses motors. They're called stepper motors. There's one back here. There's one way back there in the back. And the third one is over here on the side. And just like you might have heard of that people talk about X and Y axis, well, that's what we have here. You have an X axis, which goes this way, left to right. You got Y, which is coming front and back, and Z, right? It's 3D. You have to have 3. You can't have 2. 2 is only 2D. 3D. So this is your Z axis. And it's a basic thing that we have here. In FDM printing, what you're basically doing is you take your 3D model, you put it in, you take the model, you put it on your computer, you put it into a software that's called a slicer. I use one that's called Cura. It's free. You put it in there, and in the slicer, it does just that. Besides slicing, which I'm going to explain in a second, it tells it how hot do you want the nozzle, how hot do you want the bed, how fast do you want it to move when it's doing the outside, how fast do you want it to move, how much info there's so many settings in there, and that can be honestly a tricky part of getting a successful print. 3D printing is not like printing on a paper printer. It's not just press print and it happens. There's a lot of tinkering. There's a lot of fine tuning and getting to know how all these things work to get a good quality print. So that being said, the slicer does that. It slices. So it takes a model like this, for example, and you can't. I don't know if you're really going to be able to see, but I'm going to try to give you a good view of this. And so if you look closely at this model, you can see that there's horizontal lines. And that's because what has happened here is the program goes through and it slices this model, starting from the bottom actually, I was doing it on the top, and it slices it into layers. And these layers are really, really small. So, like really small. 0.2, even less, millimeters. That's a little teeny. I can't even demonstrate that with my fingers because it's that tiny. It's actually, you might have seen there's a little piece of paper here that we have in the back. And the reason that this piece of paper is here is because this is for leveling my bed. So I want the nozzle of my printer, when it's level, to be the thickness of a sheet of paper. The thickness of a sheet of paper, right? That's what we're talking about, the thickness of each layer. So when it slices it into tiny layers, and it basically says, okay, I'm going to draw this layer. It gives that layer X and Y coordinates, which tells the computer, hey, start this, make this come out, this plastic fish line, push it out at whatever speed. So this one pushes it out. This is basically like a hot glue gun. So it just basically heats it up. Just like when you use a hot glue gun and you push the trigger, that's all that this does. This is pushing the trigger at a very controlled speed. This nozzle is really just like the nozzle on your glue gun. So it's melting the plastic, it's pushing it through at a certain speed, it's heating it to a certain temperature, It's doing a whole bunch of stuff. That's all then in your slicer figured out. It creates something called G-code in this format. And the G-code is basically, you can look at it. It's just a text file. And when you look at it, you can see. It says, whoops, good catch, huh? When we run the calibration, this corner right here by me becomes 0, 0. So all it does is say, start printing at coordinate whatever, right? So you have your X coordinate and you have your Y coordinate. So it says start at 50 X and 50 Y. So now you're out here. So here, and now it says, okay, turn on that one to push it out. And then it pushes it out, and then it says, go from 50, 50 to now 50, 100. So now the thing is going to push this out, and it's going to go to the next point. It's very simple, actually. The design and what's going on is very simple. It's just stacking layers. It's drawing a picture.
Don't forget to
and
smash
going
the
up, that's where it
subscribe
gets the Z. It's going up whatever layer width I tell it for resolution. It goes up and it prints the next one on top. And it goes up and it prints the next one on top. And it continues until you get this, which is pretty amazing. It is really amazing. I'm still amazed by it. I've been doing it a long time and it's pretty amazing. So, that being said, you might have noticed the nozzle is starting to drip there. We don't really want it to drip. So I'm gonna grab, I usually just use like a piece of paper, another piece of paper. This here, be careful, you know, I'm not trying to get anybody hurt, but this isn't really hot. I'll take this other piece of paper. I should have a little trash can, I do, but it's just not handy right now. And I'll just kind of gently wipe this nozzle so that it's kind of clean, because you'll get some buildup from the plastic dripping. And the leftover one that was from the last model turns off when it's done, so it leaves plastic on the nozzle sometime, and you can see there's a little like residue, whatever. Now what I'm going to do is I'm going to go back to my control. I'm going to turn the temperature of the nozzle. I'm going to turn it down to about 150. That keeps it warm so that I can properly calibrate, but it's going to make it so that it stops dripping. Because if I leave it at 200 where I wanted to get it real nice and hot so I could clean it off, it's going to just keep dripping and I'm never going to be able to clean it. So now it shows me over here, it's now at 187, 186. This is all Fahrenheit. Actually, I take that back. This is all Celsius. I don't know why I said that. It's really hot. That's why I was thinking, like, wait a minute, that's not hot enough. So I'm wiping the nozzle carefully not to get burned. I'm rubbing the tip of it a little bit so that it doesn't have any buildup as it cools. If there was anything dripping, I'm going to go ahead and get that off. Because when I calibrate, I don't want it to have any, because like I said, we're dealing with point something millimeters, so even the little bit of drip that winds up out of the nozzle is going to cause a slight variation. So I'm down in the 145 zone, feeling good about that. So the next thing I'm going to do is I'm going to tell it to do an auto home, which is kind of a neat thing. What it does, and you'll see, is that it's going to move the bed and the XYZ to its furthest position. And there's a little micro switch here you might be able to see. It's a little micro switch, so it goes in each direction to a point where there's a micro switch here, there's a micro switch here, and the other one's there in the back. So it goes to each limit, and it goes, okay, I know I'm at the limit, so I know I've now calibrated myself. So let's go ahead and do that. We're going to go here and tell it auto home, and you're going to see it's going to start to move. Don't get scared. You see I have my GoPro. Sometimes I film videos. This is my GoPro 11. I'll do time lapse or whatever. I can actually, because this is fairly small, I can clip this just right here on the edge of the bed, not too far, and I can shoot a time lapse with this, which is pretty cool because then the model is in the same, the model's not moving around in the picture or whatever, but so that's handy. So here, I thought I did it. Huh. See, I talk too much sometimes. Auto home, here we go. And there it goes. So now it just went to the left. It was already left. It just went to the back. So it did X, it did Y, and now as you see, it's lowering itself down till it's going to hit this little micro switch here. And the stepper motor on the side is what's making it go. And there, it just hit it, and it says, okay, I'm there. So now I'm going to, what they call, disable the steppers, so I can move this around. So what I'm going to do is I'm going to bring it out here to the corner, roughly, you know, where I'm going to be printing. And I'm going to take my little piece of paper, and I'm going to put it under there. And it feels pretty good. I've been printing on this, so what I'm feeling for is it easily slides in between the mirror and the nozzle, but it just barely starts to rub. You can feel the paper actually start to rubbing. Now this is something that takes a little getting used to. I've been doing it a while, so I'm pretty good at it. Sometimes it's harder than others. There are these printers identical like this, which has a little attachment here, which is a laser, and it's an auto leveling system. It doesn't actually move the bed. What it does is it tells the computer, hey, the bed is slightly off level. The computer recalculates for the fact that it's slightly off level, so it can actually do it on its own. I never really had one. I never really got into it. Once you actually can do it yourself, I don't really know that you need it. But you know, if you want to use it, put your comments in the below if you guys have any experience with it. Please, you know, if you think auto leveler is the best, I can't believe this guy's still not using an auto leveler. Hey, you're entitled. I think it's cool. Subscribe to our channel. We'll talk about it for days, right? So here we go. Keep watching because we're gonna see all kind of cool stuff. Watch till the end. Like our channel. Subscribe. You might have noticed I went from this corner to this corner. When you're leveling, you want to work corner to corner. Just like when you change a tire, you want to tighten your lug nuts from in a cross pattern. It's the same thing with this. That one was good. This one is good. So I don't want to jinx anything, or as I call it, I don't want to horse mouth it. But here we go. This one is a little bit loose. I'm not really feeling any kind of pull on it at all, so I'm going to reach down here and grab one of these cool wheels that I printed, and I'm going to turn it in a counterclockwise direction, and there it goes. Just a little tiny bit I turn. I'm actually going to go back just a little tiny bit. I might have turned that, honestly, a 1/16 of an inch, or just, you know, 2-3 millimeters for those people who speak that language. So it didn't take far. And it doesn't take much more than that till it's too tight and it's gripping too much. So now I'm doing the same thing. I'm working in my diagonal pattern, and I'm going to check that one. This one feels a little ever so tight, so I'm going to turn this thing, you know, righty tighty, lefty loosey, right? It's the same thing. The only thing you have to remember is you have to use that rule as if you were looking from the bottom. So, you know, there's a little bit trickier, but we can all imagine what it looks like. This one was pretty close. I moved it just a few millimeters, or maybe a 1/16 of an inch. What you're supposed to do next, I'm not going to do it. I'm going to skip that step because I'm feeling a little confident here, and I did print on this recently. You don't really have to, like, every time recalibrate. But every so often, you know, I do it every several prints. I don't wait a whole long time because I don't want my prints to look bad. I want them to look good. So anyway, what you normally would do now is I go through the auto home method again, so that, and then let it re-auto home and then recheck it. And that's really what you want to do if you're trying to really do a proper calibration. But we're not going to do
Don't forget to smash the subscribe button.
So I'm going to go ahead and I'm going to move this up because it's right against the glass at this point, and I'm gonna raise it up. I'm gonna raise the roof, because I want to use glue stick and it's going to be in my way. So like I said, this is 500 millimeters tall. So I'm going to bring it up, you know, just a couple hundred maybe, just so enough so I could get this out of my, you know, I want to use glue stick, right? So there we go. Now, when you make the model, it's going to place them, unless you change it, it's going to make them, when you slice them, as if it's here in the center. I'm only going to print a single one of these right now because I'm actually getting low on filament. I don't want to run out. Mine doesn't have a thing where you pause it. Some of them have a sensor, it'll pause, wait for you to change the filament. Mine doesn't have that. If I'm going halfway through and I run out of filament, unless I'm here at the moment to feed it some more, my print's going to fail. And if I'm doing multiples, they're all going to fail because it's building this way. It doesn't build one in the next. It builds them both coming up. Point being is, when I do two, they're next to each other, as you'll see in the time lapse like this. So I would then want to put my glue stick on this whole section here. Because I'm only doing one, you'll see I'm only going to do this center portion, because basically what it's going to do, it's going to print that in the middle. It's going to do a little border line around the side. And so I don't really have to go much more than this. If I don't measure exactly where center is, then I'm going to do a little extra just to make sure. I usually do kind of a back and forth pattern. I try not to get these big lumps like I just got, but it doesn't really matter. The only disadvantage is the bottom. And this is the part of the crazy part that I was going to tell you all, is that it's such a small amount that the texture of this glue stick on the bottom, you'll see that. You can't see it in here, but you'll actually see that on the bottom of the model, which is crazy because it's just glue stick. All right, let's get this going. I'm gonna go here. We're gonna print from SD card. I'm gonna go to the one. I've got a few different choices of ones that I put in here. There's hats, there's pumpkins, there's two hats on one, etc. So I'm just gonna go ahead and do the single pumpkin, because I don't want to run out. I hope I actually have enough to do that and don't just waste my time. I kind of feel like I want to put a little bit more glue stick over here. Okay, so I started the print. I like to print from the SD cards. You can actually connect it to USB to your computer and print directly, but then it depends on your computer being on and communicating. If you reboot your computer or something like that, you're going to mess up your print. There's a method, and I've used, you use a Raspberry Pi. I'm going to move this out of the way. This thing's going to start to go crazy. Raspberry Pi, you can set up something called Octoprint, and it acts like a little print server. It's actually really, really cool. You can log into it through a web interface, and it lets you control the printer. It lets you monitor the printer. It'll do time lapse, really cool time lapse, because what it actually does is every time it moves up in the Z, right, when it moves up this way, every time it does that, it actually takes a picture right at the time that it moves up. And so the cool part about that is the model doesn't move. You don't see the movement like you will in mine of the actual print head moving, because it always does it as it's moving up a step. So it's a really cool time lapse it does. But you can actually monitor it. You can hook a webcam to the Octopi. They call it Octopi, which is Octoprint with a Raspberry Pi, for those who don't know. You can hook it together so I can log in through a web thing, and I not only then can record my time lapse or record a video, but I can just sit and watch it. I can monitor. It can alert me if something fails. If I look at it, and sometimes prints go kind of haywire. If the print's gone haywire, I can stop the print. It's pretty cool. I'm not doing that much printing. I don't really need to get that complex. I'm kind of taking it in a simplistic form. It works for me. I do make gifts for people. I'll hand paint them. I've made some very utilitarian, I don't know if that's a word, utility parts that are cool. solve some problems for myself, for friends. It's really cool to have one. I love having one. It just finished heating to the temperatures in the G code. I told it to print 200 degrees Celsius for the nozzle, 50 for the bed. So it finally reached that, and now it's basically doing the same thing as we talked about the auto home function, where it's calibrating itself. It went to the side, it went to the back as far as it could go. Now it's going to go all the way down. The newer version of the slicer software that's cool is, instead of it, this has to start getting flowing before it prints, otherwise you're not going to get much. So the new software, as it's doing now, it prints a straight line all the way back, comes back. So I don't know, you can't see, but the beginning is very dotted because the plastic's just getting going. So it kind of does this to make sure that the nozzle's really ready to print by the time it does this. It does now. It's going to do an outline of the print area, and it'll do the shape of the model, leaving a small margin. And now it's going to start doing the model. It's actually printing that first layer. Now, certain parts of this model, of any model, may need what's called supports, because it's really hard for it to melt plastic and go across this angle, because the plastic's going to want to sag because it's hot plastic, melting plastic. So what will happen is the software will generate, if you tell it to, what's called supports, and it basically, there's different types of supports, and some of them, they connect here, some of them don't. There's a newer type that they call tree supports, which are really cool, because if you use regular supports, it would be here on the bottom side of the eye socket, and then when you took the supports off, it's going to leave a little bit of a not smooth surface. So they have these new ones that are called tree supports, because basically they start at the bottom, and then like a tree, they'll come around and then they'll just kind of swoop right in, right where they need to. So you might see a little bit here, but they're actually really gentle with that. When I've used other supports, you get like a lot of little roughness here. Not with tree supports, it comes out really nice. This model prints really nice. I love this model. The bottom right here you may see is a little bit weird because of the same phenomena. The angle is so steep, and while it tries to print the supports, it does better in some places than other. But especially on this, why would you notice?
Don't forget to smash the
Some of
subscribe
the 3D
button.
prints you'll finish, like this one I did. This looks totally like a commercial piece that's on the side, but that's because I use spray paint auto filler, which then fills in all these, because there's very small, I don't know if you can hear it, there's very small lines here, and so if you were just to paint it without doing anything, if you look closely, you can see the lines where you've painted. So you either with a lot of layers of paint, or you can use a primer that has like a filler kind of in it, so it kind of fills these in. There's resin, clear fiberglass resin that people use. You can put on here, it fills in the gaps, and that way when you paint on it, it looks smooth. Or you can just go with the fact that you don't really care and it looks cool. This model in particular, it's a pumpkin, so it just looks cool. It doesn't matter if it has these lines. And the fill, you can choose what kind of fill that's in there. And so on this model, again, because you have so much, you're going to put a light in here, so you can then see the fill. Like this has some squares in it, and when it's lit up, you'll kind of see that honeycomb kind of looking effect in there. So that's all part of the coolness. You don't want to print this thing too dense. You control how much the fill is when you print it. So if you were to print this with solid 100% fill, you wouldn't see much of the light through the plastic. You'd still get in the eye sockets, but I like to see the whole thing kind of glow like a ball of fire. And then they've made the mouth inset, so the mouth is it's thinner, it's gonna glow a little bit brighter, and the eye sockets and nose are open, so they're obviously gonna be pretty bright. So, you know, that's all part of knowing how to slice it and all that. There's a bunch of steps. This model here, you say, wow, you've been printing all this time. Has it done anything? It looks like it's just barely starting. And yeah, you're right. It's just barely starting. This form of 3D printing is really slow. This one piece, this one model here, takes almost 8 hours to print one. When I print two, it actually takes, now that I think about it, it actually takes slightly more than double, which isn't typical, but I guess there's a little bit of movement between. Sometimes printing two is slightly faster, but there's a lot of variables in there. So yeah, it's about 8 hours for this. This is slightly less. This is about seven hours, maybe. No, it's about 6 hours. So between this and this, you've invested a lot of time of this printing. Now, I don't have to sit there and watch it, but believe me, you won't be here when this finishes. You're not going to even be here as this thing grows to be much more than it is now, because you're probably bored and like, okay, well, let's see it happen. So, as I said, you're going to see the time lapse. You're going to see, it's going to be two of them, but you'll see it grow. You'll see the tree support. This is hand painted, like I said, so that you won't see it, but you've basically seen the process. I'm taking you through the whole process from the time you have your sliced G-code on your SD card to this will be this. And then you'll have to change this for the black, which is this one here, right? And you'll have to print the hat, and then if you want to get carried away, you can paint it. There are 3D printers like this that can use multicolors and do some of this, but it's really takes a long time. There's a lot of waste. It's kind of difficult. I haven't gotten there. I guess I'm probably just a little bit jealous that I don't have one, but I manage like this. It's not a problem for me to do some like little model painting, that kind of stuff. These spools are 1 kilogram of filament. They can print a lot of, like for something like this with low fill, they can print a lot. They cost anywhere from about 15 to, I'd say 15 to 25 is the average. You'll find one that's really cheap for some reason, and you'll find some that are more expensive. I have some that are composite PLA plastic with wood, real wood. They have a really wood feeling. They have a sound of wood. They can be sanded and painted. They have carbon fiber filaments. They have clear. They have glow in the dark. There's other types besides just standard PLA that do all kind of other stuff. It's really cool. It's really gratifying to be able to do that. There's a site on there I should tell you about. It's called Tinkercad. It's a very basic CAD program, but it's very powerful. It's online. It's web-based, tinkercad.com. It's free. You can do your own models. They may not look fancy, but you can do some pretty cool ones, and you can do some very useful things. I recommend it. I would say get into 3D printing. You'll really enjoy it. You probably want to be a tinkerer because it's going to take a little bit of patience, and you're going to get a little frustrated. But as you get through it, just like everything in life, it might be a steep hill, but once you get over that little hump, things become much easier. And not to say that it's a smooth, perfect road, but it's not that bad of a climb from that point in, and you can sit down at your printer and bang out a print pretty quickly, pretty easily, and it's very gratifying. When people see this, they beg me to make them these, and it's just a very simple toy. Adult people, kids, everybody loves them. There's lots of things you can do. Like I said, gifts, things for yourself, useful things, adapters, whatever. I've made phone mounts for my car. I've made all kind of things with my 3D printer. So subscribe to our channel.
All right, folks, and remember, in a world of wonders, it's a wonderful world. We appreciate you. We'll see you next week. More exciting episodes to come. Don't you forget about us.